Hello everyone. My name is Lindsay Zhang, and I'm a chemical engineering PhD student from the Language Lecture Connect group. Today, I will talk about the story behind this image. So, micronutrients are an essential part of our daily food. However, in many communities around the world, especially in low to middle income countries, local food products are lack of important micronutrients such as vitamins and minerals. And a chronic lack of these micronutrients is leading to the hidden hunger crisis, which is affecting about 2 billion people globally, which accounts for about 7% of the global healthcare burden. And to combat this global micronutrient deficiency crisis, food fortification has been shown to be a cost-effective solution with wide range coverage, especially for those targeted regions. So specifically, food fortification is defined as a practice of improving nutritional value for those commonly consumed food products by adding vitamins and minerals. And because it is the local food products that are added with micronutrients, the food fortification strategy is independent of the local healthcare system and therefore provides very high program sustainability. However, at this stage, food fortification strategy is not being beneficial for those most marginalized communities because of two main technical barriers, including stabilization of micronutrients under those common cooking and storage conditions, as well as the release of micronutrients from the oral digestion process. And overcoming these barriers are especially important for applications in those marginalized regions because those regions are usually lack of vacuum packaging or cold chains. So in our group, we have developed a polymeric microparticle platform for micronutrient stabilization and delivery. Specifically, we first synthesized a group of novel biodegradable polymers named as polybeta amino ester, PAE, and then we fabricated PAE microparticles encapsulated with micronutrients using the oil-water emulsion method. And here we included a picture of the PAE microparticles with vitamin A and also an SEM image of one single particle, which is part of this colored awarded SEM image. And this kind of SEM images provide a lot of valuable information for us to study the protection mechanisms and also the microscopic properties of these particles. So by encapsulating by encapsulating this micronutrients in the PAE microparticles, our technology has a huge translational potential to overcome those aforementioned barriers. And here we used vitamin A as an exemplary micronutrient. So first, under a mimic of cooking condition, which is boiling in water for 2 hours, our microparticles can provide protection for over 80% of vitamin A in that condition, compared to less than 10% of recovery for the unprotected form of vitamin A. And also, under the accelerated storage condition, over 75% of vitamin A was recovered from the PAE microparticles after 1 month storage, while for the unprotected vitamin A, all of them degraded under the same condition. And this fabulous protection efficiency did not compromise with the rapid release of the system. So after 10-minute treatment of stimulated gastric fluid, which is a mimic of the stomach environment, over 90% of vitamin A was released from the system. So finally, I want to acknowledge my advisors, Anna and Bob, for their support and also our micronutrient team. And I want to give special thanks to David and Abigail from Core Facilities who helped us with the SEM imaging. And finally, special thanks to the Bill and Melinda Gates Foundation and our program manager, Deepika, for their support. Thank you.